Hi and welcome to the third section of this course, Recommendation Engines Explained. In this section we'll learn about various types of recommender systems in detail. This section explains neighbourhood similarity-based recommendations, personalised recommendation engines, model-based recommender systems, and hybrid recommendation engines. This section will demonstrate the following topics: nearest neighbourhood-based recommendation engines, content-based recommender systems, context-aware recommender systems, hybrid recommender systems, model-based recommender systems. Now we'll see the first video of Section 3, Nearest Neighbourhood-Based Recommendation Engines. In this video we'll learn the functions of nearest neighbourhood-based recommendation engines. Evolution of recommendation engines. The first generation of recommendation engines is called collaborative filtering or neighbourhood method recommenders. Though they perform very well, these recommenders come with their own set of limitations, such as cold start problems. They fail to recommend products to new users with no rating information and recommend new products with no ratings to the users. Also, these recommenders fail to handle scenarios where the data is very sparse, so the user ratings on products are much less. In order to overcome these limitations, new approaches have been developed, which we will see in this diagram. In the technology aspect, the recommendations are moving from machine learning approaches to more advanced neural network deep learning approaches. The idea for neighbourhood-based recommenders is very simple. Given the ratings of a user, find all the users similar to the active user who had similar preferences in the past, and then make predictions regarding all unknown products that the active user has not rated but are being rated in their neighbourhood. While considering the preferences or tastes of neighbours, we first calculate how similar the other users are to the active user, and then unrated items from the user community are recommended to the user following predictions. Here, the active user is the person to whom the system is serving recommendations. Also, since preferences or tastes are considered collaboratively from a pool of users, these recommender systems are also called collaborative filtering recommender systems. In these types of systems, the main actors are the users, products, and users' preference information such as rating, ranking, liking towards the products. This image is an example from Amazon showing a neighbourhood case. These neighbourhood methods are employed when we have only the user's interaction data of the product, such as ratings, like, unlike, view, not. Unlike content-based recommendations, which will be explained in the next section, they do not consider any features of the products or personal preferences of the user for the products. The collaborative filtering systems come in two flavours: user-based collaborative filtering, item-based collaborative filtering. User-based collaborative filtering. Let's try to understand user-based collaborative filtering with an example. Imagine we have a dataset used in Section 2, Build Your First Recommendation Engine, containing the reviewer's ratings given to movies on a movie review site. The task at hand is to recommend movies to the reviewers. Before we learn the recommendation approach, the first step is to analyse the data at hand. Let's analyse the data step by step. A collection of users who have interacted with the application. A movie catalogue of all the available movies. We have individual users' ratings of movies. The first step is to find similar users for an active user and then suggest new movies that this active user has not seen but similar users have seen. This can be summarised in two steps. 1. Calculate the similarity between users using the rating information of the movies. 2. For each active user, consider the movies that are not rated by them but rated by other users. Predict the unknown ratings for the non-rated movies for the active user. In this tabular data, let us recommend new movies to our active user, Jack Matthews. The first step is to look for similar users to Jack. We observe by looking at the dataset that Mick LaSalle and Gene Seymour are very similar to Jack Matthews. The similarity between users is calculated based on the ratings given by users. The most common approaches for calculating the similarity are Euclidean distance and the Pearson correlation coefficient. For now, we choose Euclidean distance to find the similarity calculation given by the equation, which we'll see here. The intuition behind using Euclidean distance is that we represent users, movies and ratings as points in a vector space with users on the x-axis, movies on the y-axis, and ratings as point in vector space. Now that we've projected our data into vector space, similarity or closeness between 2 points can be calculated using Euclidean distance and the Pearson correlation coefficient. Using the previous equation, we can calculate the similarity between all the reviewers as shown in the table. We observe from the table that our active user, Toby, is most similar to Lisa Rose. As a second step, we predict the ratings for the unknown movie Just My Luck for Jack by calculating the weighted average of the ratings given by other reviewers for Just My Luck. The rating for Jack for the Just My Luck movie is given by this equation. In this equation, we have multiplied the similarity values of all reviewers with Jack by the ratings given by them to the Just My Luck movie, and then summed all the values. This total sum is divided by the sum of similarity values to normalize the final rating. Similarly, we can predict unknown movie ratings for all the reviews, and recommendations can be made. Item-based collaborative filtering. Item-based recommendation engines handle these shortcomings by calculating similarity between items or products instead of calculating similarity between users, thereby reducing the computational cost. Since the item catalogue doesn't change rapidly, we don't have to recompute calculations very often. There are 2 steps for an item-based collaborative approach: calculating the similarity between items, predicting the ratings for the non-rated items for an active user by making use of previous ratings given to other similar items. The most common similarity measure used for this approach is cosine similarity. Cosine similarity calculates the similarity between 2 n-dimensional vectors by the angle between them in the vector space. Cosine similarity is given by this equation. When applying cosine similarity to recommender systems, we consider the item column as the n-dimensional vector and the similarity between the 2 items as the angle between them. The smaller the angle, the more similar the items. From this table, we see that You, Me and Dupree is the most similar to Lady in the Water. We now predict the rating for the Lady in the Water movie by calculating the weighted sum of ratings assigned to movies similar to Lady in the Water by Toby. That is to say, we take the similarity score of Lady in the Water for each movie rated by Toby, multiply it by the corresponding rating, and sum up all the scores for all the rated movies. This final sum is divided by the total sum of similarity scores of Lady in the Water given here. Similarly, we can calculate ratings for all other users for movies using the preceding equation. Pros and cons. Easy to implement. New items are recommended to users, giving a surprise factor to the users. This approach performs very poorly if we have little data. This approach fails for new users where we do not have any information about the users. Nice! We've successfully learned about the nearest neighbourhood-based recommendation engines.